Hi, I am Ricardo José Passini and I am a PhD student in Chemical Engineering at Federal University of São Carlos. I will present the work entitled Cu-oxo species in ferrite zeolite as active sites for the selective direct conversion of methane to methanol. A promising pathway for direct conversion of methane to methanol over heterogeneous catalysts, like metal-loaded zeolite catalysts, have emerged a potential because their high methanol selectivity. The methanol is an easy-to-transport liquid fuel and feedstock to produce commodities like the methyl ether, formaldehyde, and acetic acid. Copper zeolites can be activated under nitrous oxide or oxygen, and depending on the structure of the zeolite, different active copper-oxygen sites is generated. The objectives of this work were to evaluate copper-exchanged ferrite zeolites as catalysts for the direct methane to methanol conversion in order to investigate the nature of the copper-oxygen species. For this, the methodology employed was a series of copper-exchanged ferrite zeolites were prepared varying their silicon-aluminum ratio, the parent form zeolite, and the ion exchange treatment time. The catalyst evaluation was performed in three steps. The first one, it is the activation at 550 degrees Celsius under synthetic air flow or helium flow. Then, the reaction at 210 degrees Celsius under methane flow. And finally, the offline extraction with water. The main physical-chemical characterization will be discussed here. It will be the in situ ultraviolet visible diffuse reflectance spectroscopy and in situ Fourier transform infrared spectroscopy with methane in the transmission mode. In this table, we can see that the presence of copper-loaded zeolite is essential to turn the catalyst active, and the catalyst denoted by 4.3 copper sodium Fer 7.9 showed the higher methanol yield and the specific activity than others. In view of the best performance of this sample, the catalyst was tested in different gas activation and this impact in the methanol yield. And according to UVV's results, it is possible to see the bis-mi-oxide decouple as active sites in both results, but only the sample activated under synthetic air flow show a band that can be associated to the precursor active mono-mi-oxide decouple. In situ Fourier transform infrared spectroscopy with methane was employed in searching of identified chemical intermediates. The infrared spectra of methane gas phase can be checked, and this spectra was different from obtained by in situ FTIR measurements, which demonstrate that the procedure adopted eliminates all the methane gas phase from the analysis environmental. The presence of the band at 3016 was observed only for the sample containing copper. Previous study by Wang et al. Has demonstrated that the vibration frequency for methoxy groups in copper dimers. In this work, we can conclude that the incorporation of copper ions by ion exchange is essential to the catalyst performance. The activation under oxygen atmosphere generates more active sites. In situ FTIR spectroscopy revealed the vibration of methoxy intermediates over copper dimers. This find could help to understand the mechanism of the direct oxidation of methane to methanol over copper ferrite. Please, if you have any question, contact it by mail. Here we can check some reference and thank you.